Hello again, everyone. Welcome back. We're going to continue on with the 2014 Csmc paper. We're going to start by taking a look at question number 3 here. So question number 3, very simple looking question. Positive integers m and n satisfy their product is 5,000. m times n is 5,000. If m is not divisible by 10 and n is not divisible by 10, then what is the value of m plus n? So the way the question is worded, right away it jumps out to us, what is the value? We should just be getting one final answer. So as we work this out, we shouldn't get possibilities. We should just get a single value. So m and n should basically be determined, or at least their value should be unique. So we could have m and n be something, and we could just switch that around and say, well, n is equal to m, that sort of stuff. But rambling a little bit, how about we just take a look at the question and see what we need to do to solve this thing. So m is not divisible by 10, n is not divisible by 10. Well, divisibility by 10, okay, so they don't end in 0. But the easiest way to do this sort of thing is to maybe look at prime factorization. Okay, prime factorization, something we should have in our toolkit. So how do we prime factorize this guy? Well, we can work at it and we can see it's going to be 2 to the 3 times 5 to the 4. We write it in terms of prime numbers all grouped together with their exponents. And you can check this out. You can work it out on a calculator. The way I did it is I said, well, 5,000 is 5 times 1,000. So there's a factor of 5 right away. And 1,000 is kind of special. It's 10 cubed. 10 is 2 times 5, so we're going to have 3 2s and 3 more 5s. So that's 2 to the 3, and then 5 to the 1 plus 3, which is 4. Okay? Now, we're told m and n can't be divisible by 10. So we'll pick one of them, we'll say m. You can't have 2s and 5s, otherwise we'd have a 2 times 5, which is a factor of 10. And the same goes for n. Now we know that m times n is equal to 5,000. So we know they're factors of 5,000. And as factors, their prime factorizations can only have 2s and 5s. So we'll say m looks like 2 to the a, 5 to the b, and n looks like 2 to the c, 5 to the d. We don't know what c and d and a and b are, but we know that m and n must look like this since they're factors of 5,000. And 5,000 only has 2s and 5s. It could be that b is 0 and a is 1, and then c is 2 and d is 5. So we can have a's and b's be zeros. But we do know that we'll only have prime factors of 2 and 5 for m and n. Those are the only possibilities. We also know that m and n is equal to 5,000. So this is going to be 2a plus c is this, and 5b plus d is equal to 5,000. which is 2 to the 3, 5 to the 4. We already mentioned that. So what do we know? Well, A plus C, that's got to be 3. And B plus D, that's got to be 4. Okay. Let's suppose M has a factor of 2. We already remarked then that M can't have a factor . So then B would be equal to 0. And then D is going to be 4 minus B is equal to 4. So then N has a factor of 5. And that means that it can't have a factor of 2. Okay, so then C is going to be equal to 0. And that means that A, the number of factors of 2 in M, is going to have to make up the difference. It's going to be 3. So M would be 8, and N would be 5 to the 4, which is 625. Now, notice that we just assumed M has a factor of 2. If it doesn't, then it might have a factor of 5. And then the exact same reasoning would show that M has to be 625 and N has to be 8. Right? We just get sort of the opposite, the reverse of this situation. Okay? But the sum, M plus N, would still be 8 plus 625. It doesn't matter who is 8 and who is 625. We still get the same value. Now, the clever amongst you might be saying, well, what if M doesn't have a factor of 2 or 5? Well, then M would have to be 1, and N would be 5,000. That's divisible by 10. It wouldn't work. So we can be pretty confident in our sum. It's going to be 8 plus 625. We can either do that in our heads or we can get our calculator. 633. Actually, before I box that, I'm going to make that 6 look a little better. He's starting to look like a G. Right? Notice that our assumption of M having a factor of 2, it didn't really matter, because the other way around, it would have to have a factor of 5. We'd still be adding 8 and 625. M plus N is the same as N plus M, so it's okay. We still get a unique value. If you don't believe me, work it out on your own. Start by supposing that M has a factor of 5. But we got ourselves a final answer, and we just quickly check. M, is it divisible by 10? No. N, is it divisible by 10? No. What's M times N? Well, if you want to, you can get your calculator out, or you can do it in your head, or you can be confident in our factorization. But M times N is 5,000. So we have satisfied the conditions, we got our final answer, and the way the question was phrased, we should only be getting one answer, which we did. So that wraps up question 3. We're halfway through the questions in part A. They're going to get a little more difficult. The later questions always are. But we'll still just need our final answer. We'll tackle question number 4 in the next video. Thank you guys so much for watching. If you like the video, give a like. If you have a question or you want to make a comment, feel free to leave a comment down below. But I'll see you guys next time for question number 4.